Thank you, Mala, and the entire FlyWire team. So I'm Wei, for those that may not know me. My lab is at Boston Children's Hospital and Harvard Medical School, and we're interested in understanding how the brain controls the body and how the body influences the brain. And to kind of better understand this, we'd like to know how neural circuits are organized across the entire nervous system. Can you advance, Amy, please? Thanks. So folks here obviously probably know that there's now a connectome of the entire adult female fly brain. Can you click again? So some of you may also know that we have a connectomic data set of an adult female ventral nerve cord. This is a structure that acts very similarly to the vertebrate spinal cord. And there's also a connectome of the male ventral nerve cord from others at Genelia. However, all of these data sets and connectomes are from different individuals. And it turns out that only about half of the neurons that descend from the brain into the VNC can be matched across these different individuals. So if you can click again. So now we'd like to introduce a data set that we've been working on, many of us. It's been a real kind of team effort across people and labs and different groups, but we call this the banc, the brain and nerve core data set. Let's see, can you advance? So this video is going to play. Thank you, Amy and Kevin Delgado for generating this video. But the banc is a new unpublished connectomic data set of the whole fly CNS of an adult female Drosophila melanogaster. So what you're seeing in blue is just a surface rendering of the whole CNS. It was acquired by an automated tape-based transmission electron microscopy setup. It has over 150,000 cells, consists of 50 million images, and the data is acquired at 4 by 4 by 4 40 nanometer voxels, which comes out to about 300 terabytes of raw data. So what you're seeing now is just kind of a small subset of the ascending and descending neurons that have recently been proofread by the FlyWire 611 team. And so I just want to thank Zeta AI for the segmentation, the CAVE team that helped us get the data into the annotation framework, and obviously FlyWire and the 611 team, and now opening it up to kind of the whole FlyWire community. I should also give a shout out to Minsu and Jasper that helped to generate the data set while they were in the lab. So if you go further, what makes this data set unique is that it is a connected brain and nerve cord, right? And so we have in the kind of whole set of ascending and descending neurons intact. And so what is in orange here, I guess, or gold, is the net connective. And that's where the ascending and descending neurons project through. So in terms of where we are in terms of proofreading, if you could advance, please. So the FlyWire 611 team started proofreading neurons around the end of last year. So at this point, or as of earlier this week or last week, there's about 13,000 neurons that have been marked as proofread. If you could advance again. And so the 611 team started with neurons that project through the net connective. So these are, again, ascending and descending neurons. So in this picture, I think you see about, or this rendering, you see about 2,000 or so of these ascending and descending neurons that have been proofread and rendered. And if you could advance again. So again, over since kind of the end of last year, there have been over 400,000 edits to generate this kind of the neurons that have been proofread so far. And this is maybe in comparison to the completed FlyWire FAFB dataset, which is I think around 3 million total edits. So we're kind of about a sixth of the way there, right? Can you please advance another slide? So in addition to edits that have been made to the segmentation, people have been also adding annotations. So there's about, at this point, over 4,000 annotations, neuron annotations. And I want to stress that these are extremely important. So people, please do contribute annotations. These make the data and data set and resource much, much more value. They add extreme value kind of biologically and scientifically to this data. So please do contribute annotations and keep contributing annotations. And maybe we can go to the next slide. And there's some stuff that's kind of on deck. So we have synapse predictions, we think it coming in the coming months. And so we're leveraging the advancements that the Princeton team has already pursued in terms of improved synapses in the FAFB FlyWire dataset. And now we're going to kind of leverage those advances in the bank. This will then allow template registration for alignment and matching cells across data sets. We expect to also have neurotransmitter predictions at some point, although we don't have an explicit timeline for that yet. And there's, if people have already been navigating through the data and data set, there are some additional features that are in FlyWire that are kind of getting ported over to the bank soon, including the light bulb feature, amongst others. And we do expect to have a preprint describing and presenting the data set by the end of 2024. Can you advance another slide, please? And so I just wanted to go over the policies for use in terms of the bank data set, because it's a little bit different than the FlyWire original principles. This is in part because this is an unpublished data set. It has not been put together in kind of a manuscript form, although we're obviously in the process of doing that, which is unlike the FlyWire FAFB dataset that came from a published EM connectomic dataset. So as with original FlyWire, individuals will take a proofreading test before being given access to the data. And then there's kind of three main differences between access to the bank as compared to normal FlyWire. Because it is unpublished yet, we ask that people do not publish reconstructions until our lab publishes or preprints the dataset, or essentially a year from the beginning of when FlyWire began proofreading. And so that's the end of 2024. And for access to this unpublished resource, we ask that, oops, if you go back, we ask that if your work after entering the bank has been meaningfully impacted by access to the data, you consult myself about authorship. And then before using previously unpublished reconstructions in a scientific publication, we ask that people contact those that have contributed over 20% of edits to those neuron reconstructions. So this is a little higher than kind of the previous 10% threshold for FlyWire. And I also want to mention and highlight again that there's the FlyWire Advisory Board that exists for, in part, if disagreements arise about access to the data or anything about the data itself. Okay, please go further. And so now is time for questions and feedback. We've already gotten some questions through the questionnaire. Hopefully we've answered some of the questions about kind of the timeline for at least where we are in terms of the status of bank completion and proofreading progress. There were specific questions about efforts to proofread motor neurons, which are a little trickier in this data set. And currently we don't have explicit laid out plans for that, but I'm happy to discuss and get feedback from people. And there it was also a question about how if there are plans to explicit plans to match the FAFB data with HemiBrain, Fancy, and Mancy, and so forth. And so again, these are things that I think are open for discussion, but we at this point don't have an explicit plan to do these things specifically.
Wait,
And yep,
would you mind if I just add one thing there
yeah, sure.
on our strategy for proofreading in the bank, which
Yes.
um, so as Wei mentioned, we started with neurons that traverse the neck connective. So those were all the ANs and DNs, and we're going back over them. We then moved on to the VNC and try, even though we don't have synapses yet, we tried to attach somas to backbones. And so the majority, you will find in the data set that the majority of proofreading has happened in the neck connective, complete neurons, but those that pass through the neck connective and within the VNC. And so, and then our plan is to move into the central brain after that. So just sort of the logic of how the proofreading will proceed. You all may know that synapse detection really helps with proofreading because we can then prioritize proofreading by those neurons with the most synapses. And yeah, I think yeah, that's all I wanted to add. So please go ahead. Sorry to interrupt.
Yeah, no, thank you, Mala. I had meant to mention those things, but forgot. So thank you. And then I guess there was a final question about when the bank is going to enter codecs, and that is definitely on the roadmap, but we don't have an explicit, like a specific date for that to happen yet. I think in part, the more annotations there are in the data, the more utility there will be in getting the data into codecs as well. And I think if Amy advances, that's the end for me. Again, thanks everyone for their interest in the data set and working with us as a community to generate a whole central nervous system connectome for Drosophila.